For Martin. Thank you, Kate. Okay, Bob. Apologies.
Okay. Yeah. Well, thank you very much for the invite. Tonight, I intend to go through this. It's really a lead up to the story of rail milling, how we got to rail milling in the UK. A touch on the technical side of rail milling, and yeah, take you through rail milling from first beginnings to where we are today. Nothing doesn't start without Hatfield, really. This is why we started rail milling. Hatfield rail crash happened on the 17th of October 2000. And then falling out from that, we went post Hatfield, mass re-railing, yeah, introduction of visual and ultrasonic inspection, and closed the network and shut down rail track. In 2002, we introduced rail grinding as a means of managing RCF and gradually built that up across the networks. And in 2012, we introduced eddy current. Now, that's an important step. Most people that were anything to do with rail management knew that our visual inspection was flawed at best. We had to write on rails to get consistency in recording it. We were just looking where we thought it was half the time. We were forever finding sites that had gone to severe without us knowing. So yeah, the introduction of eddy current was a critical turning point really in the management of RCF. And one thing it proved to me was I was an Anglia rail engineer then as a route engineer, and I ran the trials for the Sperry doing the eddy current testing. And I suddenly got to the point where, oh my God, I've got so much more RCF than I thought we had. And how the hell am I going to manage this? I haven't got the money to re-rail all this. What are other people doing? I was really proactive in grinding on Anglia. I grabbed every grinding shift going, and still it was ripe on my route, and so much more than we knew about. So I went off to Europe and I found out about rail milling, and I talked with a couple of companies, Deutsche Bahn, SBB. They were all doing rail milling to manage their RCF. After amount of coaxing, we got a trial set up where we had a small truck come into the UK. And then we had, as part of the study, it was convincing the business that we needed something else apart from grinding to manage RCF. So back to Hatfield again, really. And it was only by luck or bad luck. They were re-railing the Hatfield site again. So the story of Hatfield was in 2000, they re-railed it. In 2004, they re-railed it again. Then rail grinding had helped it get to 2014. And they were back at the point again where they were re-railing again. So I took 3 rails out of the actual derailment point of Hatfield, and I took them to Switzerland. And the only reason we took them to Switzerland, it was the only place we could find a static rail milling plant that emanated a rail miller. We could have used it in a factory here, but we had no cutters to make. So we took them to Switzerland and put it through their plant. I'll visit more on that. I've got a slide on that. And that led to, we proved the business case, and finally in 2020-21, there was a delivery of network rails for first rail milling machine. It's a duplex machine. It was the second one in the UK. Crossrails had an MG31 delivered first, but ours is the first in anger working for network rail, because Crossrail was behind with their project. So touching on Hatfield and the rails going to Switzerland, as I said, these defects have been growing in there 10 years until they reached the point where they had to do, I think it was re-rail within 4 weeks. So they've got to a serious stage where they had to do something reactive to Hatfield again. It's worth noting that the rails at the time of removal had only got 3 millimeters of material missing from new. Yeah. So with wear and grinding over 10 years at Y0, and Y0 is the centre of the crown of the railhead, anyone that doesn't know, there's 3 millimeters down. I processed these through their static milling plant, and basically we've done two things as we did the trial. It was, the first thing was could we mill out RCF and get rid of it? Was it feasible? And two was actually to sense check. There was several other eddy current systems on the market, and we got them all to report their maximum depths per metre, and we could do a sense check on other systems as well. So we were taking small cuts. We were down there for nearly 2 weeks cutting rail. And it was only 60 metres. Just out of interest for you guys, Hagendorf is SVB's central delivery point for Switzerland, and they recycle all their rail. So they've got, you can go there and they'll bring in rails off of branch lines or anywhere. They'll reprofile the railheads, they'll cut all the welds and joints out of them, they'll flash cut them together. You can go there and get, I don't know, any rail, anywhere, in any length. So that they send out 600-foot rails that might be £113 or UIC 54 at 600-foot lengths, and they send it out. You can buy it. It's really good plant. So we carried on milling and milling, milling, and eventually we took off 6 millimeters of material and we cleared out all the defects. So the rail was back to good condition again. That would have left 3 millimeters of rail life before we got to minimum rail depth. And as we'd used 3 millimeters in the first 2 years, that led us to the presumption that we could almost double the life of the rail. If we'd have been able to treat it in sight, we could have doubled the life of the rail. Just, I wanted to do benefits and get it out of the way, really, up the front end. This is from, I'm a director of Linsinger UK. I talk to customers all the time. I talk to other people throughout Europe. And what's becoming evident is that rail milling is reducing general rail defects. Now, I was always a foot in both camps. I believe that milling and grinding was the strategy. And I think we've got to revisit that and have a look at that again. I've been talking to Network Rail's technical authority to manage a route where we do milling on one road only and grinding on another to see the difference for UK traffic. Ireland were the first people. They seem to have turned their network round, but they did nothing to their network beforehand. But they come up with this, they reduced all their rail defects by about 80%, and that's huge for any rail engineer. I thought that was because they did nothing. Yeah, that's what I thought. I thought, well, they don't do any profile management. Understandably, it's got to be better. Yeah. And then Holland switched before we ever went rail milling. They went to rail milling as well, including installing a static plant, and they mill every rail before installation now as well, so that their whole network is always milled. They were reporting between 60 and 75% reduction in defects in their track. And the latest one to come to the table is Denmark. Denmark was a route where they did cyclic grinding, same as we do in England. And they've switched some of their main lines over to milling strategy. They've done away with all their cyclic grinding, and they're reporting 80%. So I'm sort of toying now with having a foot in both camps to say, well, there's two tools, and you apply the right strategy to say, well, actually, is there something in this what should we investigate? Another benefit, it's the green credentials milling. Yeah, we pick up everything we take off the rail, we pick up and take away, so it's all recyclable. Our machines are very efficient, and Andrew Hames, actually one of his podcasts, said that we're one of the main contributors towards UK Rail's net zero targets, and rail milling should be thoroughly incorporated as business as usual within Network Rail, which is good to hear. Question for the room, well, or anybody. I reviewed all the data that took the first 2 years of milling on Network Rail, and I took the cost of the milling train, I took the cost of all of the routes, what they have to pay for the milling train, and I referred it again and looked at the yardage they covered and referred it as a 300 or against a rate of £350 per metre for re-railing. What do you reckon we saved? Anyone want to guess in the first 2 years?
I could tell you in Scotland.
Yeah.
The first 2 years, I don't know, because there was a problem with the link gear, was new. I don't know if you remember the 150 meter radius problem, but probably if everything had worked, probably 2-3 million only in Scotland per year, minimum.
Minimum.
So in the whole island, sorry, in the whole of Great Britain,
We've just discussed one on that.
I don't know, like perhaps 10-20 million in 2 years.
Our caveat this was the first 2 years, the machines were grossly underutilised. Yeah. Nobody knew about the length of planning, so the sites were all small. Nominally, they were tackling. So you'd say it wasn't best used. 500 million
In 2 years.
in 2 years.
Do we really done that out of re-railing?
If not, why are you milling it?
I guess you could say we've doubled the amount volume we could do if it's
Yeah.
worth the cost.
Yeah.
You know what I mean?
But that's the simple figures. The yardage we covered, as a national project, if you times that just by the 400 per metre, that was the number it gave us after all the costs you paid. It stacks up. Germany have increased their milling. You know, they've gone from 5 machines when I first spoke to Deutsche Bahn 10 years ago. They've now got 12. So it's a big number. The only thing I would say back, Lynn, is perhaps all of it's not been treated, so all the cracks are removed. Yeah, I'd say that's a fair comment. A little bit about Linsinger themselves. I've got to do the corporate piece. So Linsinger, the inventor of rail milling, they were the first people. They've been milling and sawing experts in the market of pipes, gas and pipes and plate for about 85 years. Located in Upper Austria, lovely part of the world, and gradually ramped the building up now where we can be building 6 machines at a time in our halls. Our latest fleet is the top of the show. It's the latest and greatest. That's the Railmaster. It's a multimodal unit, so you can have whichever power unit you decide you want on it. It can be hydrogen, it can be overhead continuing, it can be diesel, electric, exactly what you want. And modules in the middle, you can add or take away as many modules as you want. You can make your machine as big as you want. MG31, that's the machine that's on Crossrail. That was the biggest and the fastest milling machine in the world. And then you've got FSO6 that the Network Rail one is, but Network Rails is actually 2 of those joined together. And we're also the first supplier to fully duplex a yellow bit of plant. Lots have tried and never managed to duplex one. FSO3 was developed for the underground and metros, featuring FSO2. Again, they're small units, they've only got one cutter. The SFO2 truck, that's what Ireland are benefiting from. So we do shifts in Ireland with 2 of those machines. And then the NG31 was really, that was designed as a containerized, so you could put it in a container and take it wherever you want. And we made that hydrogen. I want to be able to get to these videos now. I'll just play a video. Please. No sound. Is that something to do with Teams, or have I got to play it on my?
You have to reshare with Teams, won't you, for anyone online to get?
Yeah, you might have to share the video itself. So
Right.
unshare it and then share again.
I'll put it.
Well, there's a button there, you click, that says share audio.
Yeah, there's a little tick box, I think. Yeah, so if you stop sharing, and then if you share again,
And then there's a, see that includes sound just beneath.
at the very top of, there's a little toggle.
Sure.
No, then. Well, I'll just play it on mine. Will that work? There we go. There you go. Austrians are really proud of that machine. We finally sold it in a trans, not last time, so 2 years ago, and it's now working in North America. And the RAM purchased it, which is quite interesting for those that know the business. They actually purchased 2 MG11s to work in North America. Moving on from Lynn Singer.
Sorry, folks, we've lost the sound for the online team.
We're not lost sound, we couldn't hear the video, that was all.
Microphone's muted. Can you unmute the mic? Control.
It says the microphone is muted.
Hello?
I think it was just the video I'm having issues with.
Can you hear me talking now?
Yes.
Oh, sorry you couldn't hear the video. We thought we'd cracked it, but it was just a room that we could hear it then. Yeah, Lynn Mag are there. Lynn, why is it not working now?
I can see it online there. Oh, okay. You just try and click it again. See the clip share. Read Gizmo. I can see it online.
There's not lights on it or anything.
No. Something there. Yeah. Yeah, that's us.
Right, reconvene. Lynn Mag are Lynn Singer's delivery agent. We go out providing service to customers around the world, really. It was to breach a hole in the market because not everybody can afford to buy. If you've only got a small network, you can't afford to buy a machine. And also, it acts as our R&D development tool as well. So Ireland are actually in a very lucky position. We do a lot of research and development in Ireland. We come on to switching and crossing milling. We do that now in Ireland. We've just got a new technology of a surface finishing technology. Basically, most of what we do, we trial out in Ireland on these trucks.
It's saying that you've got a microphone issue, so I don't know whether I can hear you. Right.
They can hear now.
Lynn Mag, say, are located in Ireland, Austria, obviously, and Australia. As I say, the advanced technology, over a decade of experience. They've been in the market for 12 years now, I think, as a dedicated force providing service. Something I know that really does make a difference. The employees they take on have to go and work in Lynn Singer factory first, building the machines. So they really do get good training from the bottom up. They know the machines inside out. In Germany, they run an MG31, the same as Crossrail. One of their highlights in Australia was actually doing the Sydney Bridge. I was going to show you Sydney Bridge, but I'm not going to do it now because it's more joy with more videos. Interesting, they couldn't treat the Sydney Bridge with everything. It's a wooden deck bridge. So they've been out there doing the Sydney deck bridge. And say in Ireland, they've built from strength to strength. It started off with one truck at 100 shifts a year, and now they've got 2 trucks up to 250 shifts a year. And if you think of Ireland, it's the same size as Scotland for their rail network. So yeah, the main thing they saw was they had reduction in their rail defects. Historically, they had a lot of dipped and high welds, and out of it came as well satisfaction coming from their train operators, because they're actually running a decent profile over their network. They've been milling out there now for 7 years, yeah. So that there's a commitment for another 8 years of rail milling to the volume of 250 shifts. They only remove 1 millimetre at a time with these trucks. So it's small metal removal going round the network, picking it off. If they come to a site where it's RCF, they'll do 2 passes, but then they move on. And then they come back to it again. Their whole idea was to get their whole network conformal first. And it seems to be working. And also in the UK. So we come to the UK for a campaign once a year, normally around Rail Live, so we can attend that with the machines. Docklands as well. Docklands used to do grinding and milling, and now that's gone to milling only as well. And noise reduction was the reason for Docklands liked it, yeah. Because you're actually working so near to people's houses, noise and vibration reduction from that. Rail milling history. There were, as I said, 1818 was the first milling machines developed for industrial use. It's a non-abrasive rotary cutting process. We do use some abrasive just as a finishing. And all the chips that are cut out of the surface, and those chips add sort of work as heat sinks, so we don't affect the metallurgy of the rail at all. All the heat goes into the chip. It was a struggle when they first started introducing rail milling, because they took what they were producing for the plate industry, and they turned it upside down and bolted it on the bottom of a train, so that everything was upside down. To believe they are high precision, they are incredibly finicky machines, rail millers. It doesn't matter which company you've go to, they're equally as finicky, because they have to be. They can so easily damage a rail if they haven't got sensors and checking everything. The challenge has always been, if you think about anybody that knows about engineering, a milling machine will normally be one of the biggest machines in a workshop, with a huge base, tool base, that you bolt or fix a workpiece to it so it's really secure. We're trying to mill jelly at times. So yeah, that is a challenge. It's a moving workpiece with variable stiffness. A bit about growth rates and cracks and where we think that people should be intervening. RCF starts off as a slow, shallow growth, and then at its optimum time, normally about 2-3 millimeters to 5 millimeters, it can suddenly turn down, and once that crack has turned down, it's off and running. There's some thoughts that once the crack has turned down, even if you remove it and leave a little bit of the crack, it doesn't shallow again. But I'm not sure. I'm not sure. We always advocate removing the defect completely for that. But then I look at Ireland, that only done a little and often a tap, and theirs hasn't seemed to be still diving, or they're treating a lot more frequently, so they are keeping it under control. But there's some people, and throughout the industry, some people say, no, it will shallow off. And then there's those that will say, no, it will carry on growing at the steeper angle. Normally tonnage driven, can be also geometry as well. But normally it seems to be throughout Europe, people end up with a reading of about 0.2 of rail damage per million gross tons. So whether it's not physical damage, it's just where you've hardened the steel, and then after a period of time, that material will damage to the point of it will fatigue and start to crack. So, but that's sort of normally accepted throughout Europe now, 0.2 per million gross tons. Looking at different strategies, I talked about strategies. We in the UK, we've got a preventative strategy really that's meant to be working. You've got your C44s and C21 grinder machines out there doing cyclical in-traffic grinding, backed up by a preventative strategy. So you go and use your the smaller grinding machines targeting sites, and the corrective strategy you've got now is that you can go to milling. As you move up, really the best strategy to have is preventative. Yeah, it's more cost effective if you can be purely preventative. I'm not convinced that corrective is somewhere we should be aiming. We seem, even now in the UK, we've got the tools, they're not being used, and all well, from what I see in the data, all the small stuff is just piling towards severe and very severe. When I looked at the 2 years worth of data I had 2 years worth of the defect data as well, and volumes nationally of RCF, despite all the grinding, despite the mill, there was 2 milling machines working for a while, and it was still static in volume over 2 years. And if I said anything, I would say there was more very severe, slightly less light and more severe, which tells me it's all shifting to the right, really. I do appreciate, I know you're hamstrung for budgets and stuff now. Just a little bit about how the milling itself works. So it's a rotational planer and it's a climb milling. So a lot of the time the machine is actually braking because the power of the milling will actually pull the machine along, as big as it is. It enters, and that's why that's how it uses the chip as the heat sink, because it takes a bigger slice to start with. So you can see one, yeah. It'll take the bigger slice at the top and then shallows. So that heat there is where you get the increase of the heat. It travels back into this part here. Full climb milling. A bit more on it. So there's your tip coming in. This part here is the hottest part of the tip. And still, that still travels back into this chip node. And it's the one good thing that we don't change any metallurgy. If you compare it against rail grinding, multiple passes, you start at 750 with one pass of a rail grinder. That is the spot temperature. And then as you do multi-passing, like if you're using a corrective grinder, there is a build-up of heat there that's getting worse and worse. And, you know, it is what it is. This is why we believe that milling has an advantage, really, in this sort of field, is not attacking or not affecting the metallurgy. So if you see the centre line here is where you're going to start to grow what they call the martensitic layer, authentic, and we sit firmly below the line and grinding sits above it. So it's always going to have an amount of martensitic or white etching layer formed, even if it's the best grinding possible. So here's some examples. We call it polishing. People call it grinding units behind the millers, but it's polishing. It moves transversely in the direction. We're not doing cross railhead, it's polishing. But even now, we see as a company, we want to get away from even using grinding stones at all. We believe to take any sort of doubt out of it, we don't want grinding stones that work on the machines. You see on the right, you can see these small, in a conventional ground rail, you end up with a rough surface. You've got to, because it's a small stone chip scooping a piece of material, and these white pieces are the martensitic layers starting to form. And again, this is just the same rails polished. These are transversal, so looking at the rail transversely, and again you see the white etching layer. This is a study done by Chinese gentlemen when they were looking at it and the behaviours of it. And again, they found that the deep scores would attract in the really high temperatures, and that was what was driving with conventional ground rail, the martensitic. Versus polishing, because it's going longitudinally, you haven't got any of these higher temperatures and super roughnesses. So we're moving away from that. Target profile, for me as a rail engineer, I think it's brilliant. I can say to a company, I want my rail this shape, and guarantee, as long as they do full head coverage, I get that shape of rail. Yeah. I used to go around doing mini prof behind the grinders when I was a route engineer, and I was forever chasing them, saying, you haven't attacked my rail isn't the right shape. And the challenge to anyone from a route base, do you know the shape of your rail out there? Do you actually look at it in detail? Do people go out and take a mini prof? What are your rails like? I used to find wherever I went in the country, if I took a mini prof, the rails weren't conformal shape, which is annoying. So yeah, one really good thing with milling is the shape you make that cutter is the shape you get your rail, as long as it's applied across the surface. Residual head height is really important for the machines and the crews, and they don't get told it a lot of the time. So sometimes they'll leave your track with cracks left in the track because they've only been told to cut to a certain depth, and they can't go any deeper. They haven't got the authority to do that. We're trying to encourage anybody planning milling to actually let them know what your deepest removal could be. So if they've got time at the end of the shift, they back the machine up and they'll take an extra cut in the areas where they've still got RCF. They've got eddy current systems on the trains, so they know if they've left RCF behind or not, where the pockets are. There's a series in the centre, you'll see a series of carbide tips. They're formed and overlinked to each other to make the profile of the rails, or the rail profile you want. Some are flat, some are curved. Tips on the flats you can use up to 8 times. I mean, and change them 8 times once their life expired. So you use 4 sides of the tip and then flip it. and a curved one you can only use 4 times. You can use milling for gauge widening if you've got problems with the gauge of your rail. We've done a lot in Germany where they've got tight radius curves and they've got gauge tightening as they're going around, a lot of problems. And I've got a few clips in here as well where we gauge widen another piece of railway additionally to get them out of a problem. But yeah, so they've used it for gauge widening without having to do readjusted all the asset really. Example here, this is I would say day-to-day work for milling is removal of RCF. Most people are using it for that and corrugation. Always to be aware of, again, it's something especially for the UK. If you tell Colas Rail you want 3 millimeters of material removed, they will take that from the high point of the rail. And you might have been measuring it at Y0. If you want them to take it from Y0, then you need to tell them. Again, it's a contractual thing. They don't want to take any more material away than you prescribe. They could be taken 2 or 3 millimeters before you hit Y0 on some bad rails where they're so worn on the gauge corner side that they hit the field side of the rail and they're coming down 2 or 3 millimeters before they're even touching Y0. Working in S&C, we can't do all S&C. We can't do the very front of the blade, and we can't do actually in the frog. Apart from that now, we've got it to a point where we can go through, we use 2 different milling cutters. So where this says in 2 treatment steps, that would still be single pass for a big machine. We've been doing it with a lorry to do the trials in Ireland, and we put 2 different profiles, so we have to do it in 2 passes. So I think safely you could say that you could treat a full set of S&C in about 30 minutes with a machine with 2 cutters. Yeah, that everyone was really, oh, you've got to get down the tips, you've got to get down the tips. I've advised them, no, we don't bother. We don't bother. We don't even do it with grinders. You know, nobody goes down that far. They're done by hand if they're done at all. So where you get to sort of somewhere in the range of about 10 to 15 millimeters, stop treating. Site selection, especially for guys in Scotland who are just about to take over. From what I see, Network Rail have got all the tools and that available. You're not allowed to do S&C at the moment, it's not approved. Yeah. Be aware the standard even tells you that it's not possible, which the new 1300 says is a red, thou shalt not do.
Are you working to change that, to change the mind of technical authority?
I've written to them and no answer as yet. But yes, so we're going down the other route. We're going to put in an official challenge to the standard.
Okay.
Yeah, because it affects us commercially. People like TransLink in Northern Ireland, who we do work for, they use Network Rail standards. Yeah, there's other people who use the standard. So there's several points that we're challenging that standard on.
Okay, that's good to know.
Production rate. I say use 1,000 meters per hour at 5 millimeters removal. Yeah, it does 16 meters per minute. It takes about 30 minutes setup time and about 15 minutes pack up time. The amount of shifts I see, I review every shift completed form. that comes in from the machine, and 9 times out of 10 there's time left on the site. They always complete the work. And when I look, there's 30 minutes left, there's 20 minutes left, there's this. Why not just plan a bit more? Why not plan a bit more? Doesn't hurt, does it? The guys are getting better and better using the NR machine. They can now push to the 1,000 meters at 5 millimeters, as long as the rail is in a fair condition. If it's a flattened rail, then they will struggle, because you're taking so much material off the corners of the rail. And lastly, use the systems that you've got in Network Rail to help your site selection. Look at eddy current. If you're looking at severe RCF in eddy current, go and look at UT data. Yeah, go and look at even P4 suspects. If you've got eddy current to 5 millimeters and you've got P4 suspects, you're going to be down in 6-7 millimeters at least, I would say, on average. So you can use that as a guide. If you've got no defects within that site, you've got RCF that's showing the 5 millimeters, and you've got no P4 suspects being reported, and you've got 5-6 millimeters of material, I'd say we better clear it out. But better really to be aiming to treat your rails at somewhere around 2.5 millimeters. That seems to be the norm in the rest of the infrastructure owners throughout Europe. That's what most of them aim to intervene at about 2.5 millimeters. So you'll catch it before it's turning down. Another one, best practice, carry out a site inspection of the works pre. Find out where your lubricators are, they've got to be took off, if there's any grease that will stop it working. Yeah, look at your rail width. You can only treat up to 75 millimeters rail width. We've had several shifts we've gone to, and the rail's been too wide for us to treat. Also, there is other things you can treat. Rail millers are very good at removing corrugation, especially shortwave corrugation rather than long wave. Yeah, it's because they've got 1.5 meters floating edge. So whereas a grinder uses pressure of stones, pressure on the rail, and they maintain that. So if you think about just pressure pushing, it's going to ride with the curves, with the ups and downs. A miller tries to lock itself, and it's measured over 1.5 meters. So it's blending the tops. That's why it's good at sorting out welds and joints as well. Yeah, as I said, please tell the in your plan. You've said, look at your max cut available. Yeah, what the machine can go to. Tell the machine people that. Let them know that, and also let them know where you want the material taken from. And that's what I say about, do you know your rail shape? Lots of people throughout the network, they'll treat the high rail for RCF, and rightly they want to put a conformal profile back on their low rail. And we see they either write 0.3 millimeter removal or 0.5 millimeter removal. If your rail isn't the right shape, we won't even touch the whole rail. There's loads of examples where we've only cut the back end of the rail, not touched the gauge corner at all. The easiest way to tell them to do it, and I thought I'd written on here, perhaps on the next one. Minimum metal removal at full head coverage. That's all you've got to say to the team. That's what you want. So basically, on that rail, they'll lower the cutter 0.1 millimeter by 0.1 millimeter, so they can move 0.1 of a millimeter per button press, basically in the cab. They'll lower that cutter until the whole rail head is covered by the cutter, and then they move forward. and that's the minimum you can get away with. And at Y0, you're probably losing about 0.3 millimeters of material, depending how low the gauge corner is. Site management, best practice. From what I see, the people that put someone out there with some knowledge produce the best results. So I see Anglia, I see LNE. I think in Scotland you have someone dedicated going out as well. Yeah, I see the best results. You know, you pay a lot of money a shift for this machine. I can't understand why anyone just sends an ES out there that is normally looking after a PWI job that doesn't know anything about it. And the machine crew say, oh, can we do this? And they just go, no, because they don't know. So it's, you know, look at your better management.
Yes.
Another one of when we're trying to treat, especially deep RCF, the cracks under the rail, you won't see them. That's why we look at them with things like ultrasonics and eddy current. In the rail, there is loads of cracks and voids and pockets of material that is totally detached from the rail. Once you start opening up the top of the rail, you will see them. We've had so many people panic at that point and go, oh my God, the machine's breaking lumps out of my rail. No, it's not. It's just showing you why we take RCF so seriously. Yeah. So you will get these horrible looking bits of rail. The advice is do nothing, keep cutting. Yeah. They will disappear. As long as you've got enough material. And that's, again, is why it's really important to have that, the value of the max material removal. And I believe the standard now says if you've got, if you leave any defects behind, you've got to treat them with a more harsher minimum action. So things we do to help people. So again, back in the Linsinger camp, we noticed Network Rail especially, we're losing a number of shifts. And you could say poorly planned shifts, but on the night, the machine gets there, the lipped rails, and they can't treat them. Yeah, and we notice this, like I say, we see everything that comes in. We see reports from COLAS and the shift returns. And then my old friend, Mr. Clements from Wales, posted on LinkedIn saying that he wanted some way of treating lipping. Yeah, because he's got a problem in Wales with lipping. So we've developed a cutter for him and for anybody else. And it's just going through the technical authority now, and that'll move us from 75 millimeters up to 86 millimeters. So if you've got a rail lipped more than that.
Has that been approved?
It's going through. I don't know where it is.
Yeah, no, that's good to know.
Yeah.
I was aware of that.
Yeah.
But
And the plan is to have the first two cutters on the machine dedicated as that. So at any time they can just drop them in and knock that back edge off. And you'll see, this is the work. I asked everybody, I kept asking, can you give me some mini profs of what you consider to be bad lipped rail? Do you know what I mean? What's yours like? And I got that off Anglia. That's in track at the moment. That's on the going round on the North London line. There's freight trains predominantly over it, so it's very flat. So yeah, we've designed it for that. If you plea that goes out, if you think you've got some lipping worse than those pictures, get me a mini prof and send them to me. I'd happily look at them and see if we can, before we start making the cutters, we haven't made these cutters yet, we'll look at, you know, adapting them to fit your needs as well. But that's the whole point. So you don't lose shifts. The first two units, they can still profile normal quality rail, Do you know what I mean? Normal rail if you need to be, but they'll sit there. And so if the guys turn up on site and go, oh, wide rail, no one told us, we can still get on with the work. Here's a really interesting one that anyone knows anything about sideware. I'm not going to tell you who the customer was. It was a European customer. It's a very nice piece of railway around a lake. And it has some serious sideware. And obviously the lip's starting to form as well, where it's actually starting to ride on the rail. For the scenic place we were in, I've never heard such a row in all my life through squeal. And they wanted a solution to buy them some time. Yeah. There's nothing we can do to recover that rail. We can't stick rail onto it. So they wanted a solution to buy them some time to re-rail because they were afraid they were going to get a derailment soon. You see here, this is obviously a new wheel that I planned on top, but they were, you know, hard on all the way up the side, sitting on top of the lip. And we delivered them this. We delivered them. Basically, we made it on an individual cutter that reinstalled the gauge corner, came down at a steeper angle, and then we kicked out the rail. You wouldn't want to do this to your rails, yeah, but it is a way of getting you out of trouble, buying them time. That's all they wanted. They wanted time to get their re-railing, and you'll see the wheels running back on gauge corner, and we're clear of the rail. It stopped their noise complaints and given them time. So this was saying we work with customers to meet abnormal needs, if you like. Basically, this gauge widened it by 5 millimeters, and their standard said they could gauge widen up to 10 millimeters anyway. So it was something I wasn't sure about when I first went there, but it has worked, and we couldn't believe we took sound recordings before and sound recordings after, and it's chalk and cheese. You couldn't hear the trains again. They were just running normally. I was going to play you a video on smart surface technology. This is another innovation of ours, and like I said to you earlier, we want to get away from using grindstones as finishing. So we've come to smart surface technology. It's shot peening the railhead after milling. British Steel first shot peened rails probably 10, 15 years ago, and there's about 120 foot somewhere in the back end of Wales. They used it to look at reducing stress around flash butt welds and stuff like that. J. Gyswell and the lot out of there. It puts the good thing is it puts a compressive force on the head of the rail. I'm not going to say that would last forever, but it's a positive rather than a negative. Totally cold process, fires the shot peens down, collects them back up again. Clever wizardry that does it. Yeah, really nice finish. Again, that's currently being worked in Ireland at the moment. So we're looking at, we've gone through trials, we're now approved, and now it's becoming business as usual on one of the machines in Ireland, and we're learning, you know, its limitations and stuff like that. But yeah, very good, a step in the right direction for us. And that's it. Thank you very much. Any questions?
Excellent, thanks, Bob. Is there any questions in the room? I've got some questions online, but I wonder if there's any in the room.
Rail defects, 80% of rail defects removed. We're only talking about superficial stuff. So while and you're saying don't look up, make sure there's no P4s before you start grinding. So we're talking about stuff without depth. So are people getting rid of squats and wheel bears and so forth when they're just superficial before any downtime?
There's a rule of thought out there that I don't, it's hard for me to say now as representing a milling company, but there's a train of thought out there that if grinding is, I'll say, isn't carried out correctly, can help generate squats. Yeah. And from what I see, the people going to milling only have removed a lot of squats from growing on their track.
So can we mill squats even deeper than the cut?
If you get them,
And what we're saying is we think the grinding's actually creating the squats.
Yeah.
You won't have squats to start with.
yeah.
No, I have a question about the sideware because my experience with Linsinger here in Scotland is Linsinger doesn't deal well with sideware.
We're not allowed to do sideware.
No, but the problem is the limit that Linsinger has is 23 millimeters under the head of the rail. That doesn't make any sense with the network rail standards. And I've had the chances that we've lost milling shifts because the machine there come like, no, we can't do that.
What sideware step were you on?
I don't remember the steps, but the thing is me talking, or my colleague talking with the Linsinger guys, oh, I've never seen an NR4 gauge. Like, how? So,
Yeah, well, they don't use, most of Europe don't use an NR4 gauge. They actually use a 45-degree gauge.
yeah, well, what I mean is Linsinger doesn't work with a network rail way of measuring sideware, and that's creating problems.
Sit down, tell us what you want us to do.
I will sit down with you, please.
Yeah, not a
Because what
problem.
we need is a conversion of
Exactly.
what their limit is in their language. We
Yeah.
just need to translate it into our snap language,
Yeah.
don't we? So we know
Yeah,
when to say, no, this
Yeah.
isn't a fit like.
Because for me, just sending a 50-gram machine plus the money that we have to pay to Jonathan,
see,
and then like, no, it has that shape, we cannot mill. It's like,
I know Mr. Streeter has milled sideware of 9,
yeah, so
and by reducing the height of the rail, decreased the sideware step.
absolutely. And I always count on that when calculating the maximum cut. Yeah.
There's some work to do, yeah, and I think for the UK we could get ourselves in a better position, and it would mean involving some coalesce people as well, so they're happy with what they're being asked to do. So yeah, happy to.
And other question is, can the machine mill any single type of steel?
Makes no difference.
No difference at all, right? So it doesn't matter if
Yeah.
it's HP or 260
No,
or whatever.
no.
Perhaps the speed of it is not. Does it go slower, for example, if it's HP rail?
Perhaps a meter a minute.
So nothing exciting.
No. If you look at Crossrail have got really hard rails, haven't they? And they're treating up to 18 meters a minute, which is over more than 1,000 per hour. So yeah, it doesn't affect it.
Okay.
The worst effect is where you're getting different shape rails. So if you've gone and cut rails in, or if there's high welds, those type of things can overload a machine, because all of a sudden you're cutting more material rather than the grade of material. That has more effect on the machine.
Some questions online, Bob, as well. So Tom Wilson has asked, does the sensitivity of the quality assurance cut-off systems increase the likelihood of lost shifts or reduced shifts output? Or are the operators trained as machine technicians or fitters to rectify these issues on site?
Yeah, they're trained to rectify 99% of the issues. Sometimes they cannot get the machine going, but normally, whenever we've investigated, unless it's been a serious problem, a failure, in normal working, we haven't done any updates to any machines or anything. It's working normally, and then all of a sudden it won't work. It's one of two things. It's either track quality or grease that affect it. Yeah, if you've got poor or very poor apes, it does struggle with that, because it's trying to chase the jelly. There's one that we were doing in the northern part, and it came out, and all of a sudden we'd done 1,000 meters, and all of a sudden we couldn't cut. It kept retracting, everything. Everyone's going, oh, the machine's rubbish. And I managed to get hold of the trap geometry trace, and the exact point where we were struggling, it was the start of a very poor. It was a super red site.
That's something that we need to start to look at.
Well, we do recommend that you tamp before milling. That's always been the recommendation. You tamp your sites before milling to achieve the best result, if possible.
Another question from Tom. When rail corrugation is severe, who determines how many milling passes are required? Is this part of the advanced planning process, or is this able to be determined on the fly?
Either. So the machine crews have measurement equipment. They can measure what the corrugation is, so they know. Again, if you gave them, if you tell them only remove 2 millimeters to remove my corrugation, they'll stop at 2 millimeters. It's very contractual with the use of the machine. So whatever you.
So we have a case here in Scotland. I think a couple of years ago, we sent the machine to Craig and Doran curve in the M7, I think it is. So Craig and Doran going to Helensburgh Central.
Yeah.
And we calculate 2 millimeters cut, and it cleaned it. But again, if 2 millimeters cut is not enough, you can look after the trim and see, ooh, not remove. You send the machine back and do another pass.
Yeah, but you're there to permit it to do that.
Yeah, well, yeah, that's a
What I'm
case.
saying is, if you don't send the person out.
Oh, yeah,
Or tell them they can go deeper.
Let's go.
Yeah, no, in Scotland, we always have a representative on during the shift.
The important thing that's been learnt about corrugation is you need to remove it all, because in the generation of corrugation, the high spots have become hard spots. So unless you remove those high spots completely, you're just leaving hard spots behind, and it'll just act as a trigger again, and you'll be back in the same boat within a short period of time.
Another question from Tom. How quickly does wear occur to the carbide tips of the milling head, and how might that wear affect the final rail profile?
It doesn't affect the rail profile. So when the tips are getting worn, they can see it by the amount of effort the cutter's using. So they can see it by the systems and the pressure they're using. Network rail's really lucky because you've got 4 cutting heads. So we just switched to a different cutting head. So you normally have a roughing cutter is your first cutter, getting your shape down, and then a defined cutter, and then they'll move back. So that normally it's the roughing cutter that will lose its tips first. So that the one that was more doing the accurate work will become the roughing one, and the next one back will become. And normally for the shifts you're doing in network rail, the machine doesn't need a cutter change. We do cutter changes with smaller machines. So in Ireland, they do a machine change. And I think it's normally with that machine about 1,200 meters. So on a long shift, we're doing more than 1,200 meters. Then they'll do a cutter change. But we do it as cutter changes, not tip changes. Tip changes, maintenance is during the day in non-productive time. So it's literally we slide one cutter off and put another cutter in.
Yeah. Another question from Tom about S&C milling. It said, is frog milling not possible due to the rail V, or does increased steel hardness play a part?
No, it's not about increasing hardness. It is about the V. At a point, we'll come down towards the point of the V, and the back edge of the cutter would strike the opposing rail.
Right.
And to be honest, I've talked to most people throughout Europe. Nobody's doing anything with machines in those areas. They all do it with a manual team or don't bother at all.
Couple of questions from Richard. Sorry, I didn't get your surname in the chat. I think you might have touched on this, Bob, in the presentation, but how does the miller manage the removal of heavier gauge side lipping, circa 3 to 5 millimeters?
Greater than, it doesn't.
Doesn't? Right, okay.
Yeah. So if you've got, basically, if you've got a rail wider than the cutter, it will leave an upstand. It will wreck the cutter. The back, the teeth aren't made to just sink down into a rail. They're meant to cut right over the rail, and they're designed that way. So there's every chance they'll break their first row of teeth on the field side of the cutter, or at best they'll leave an upstand. We had it in Liverpool when we done work with the milling truck in Liverpool with Mr. Benson, and we had to get a wider cutter and cut the back edge off.
Question in similar lines, I think. Can gauge corner relief be added, or is the tool a set profile?
It's a set profile.
Right.
So you've got two. Yeah. You've got your standard profile, and then you've got your NRHR1, which gives you your 0.2 relief on the corner. I think that's all they're using, isn't it? I think they're applying NRHR1 everywhere. I don't think they're using standard profile.
I don't know.
By standard profile, you mean what it looks like new.
Yeah, UIC 54 or UIC 60.
So that's not what we want, is it? Because rails aren't delivered designed to be what they need to be.
Yeah, but they bought cutters of both because straight track, technically.
I guess it could be.
Yeah, but
with standard profile, whereas you want the gauge really.
But I think you'll find they're just putting NRHR1 everywhere.
Rami has asked, does milling introduce residual stresses to the rails?
No residual stress at all. Good or bad.
Right. Tom, again, is interface between the milled and non-milled railheads blended in manually or automatically by the machine control system?
So
Blend out, so if you're doing 5.
Oh, as you're blending in and out.
Yeah.
the machine runs in and out.
It's such a gentle, it blends in at 1 in 2,500.
Right, okay.
Yeah.
Yeah.
So as it comes in, it's such a slow feed. In fact, we're trying to make it so it's not as slow.
Is there any way we can make that distance shorter?
Yes.
We're working on that
You're
now.
working on that?
Yeah.
That's good.
By automating, when the majority of times is when we caterpillar over something, yeah, a treadle, let's say a treadle. So we have to pick up, all the copy fingers come away from the rails, that's what's used to guide the machine. And then we go back down on the rail, the copy finger has to relocate the rail, and it's all time and distance. So we're just working on a stability program where we pick up with lasers. So once the copy fingers have come away, we're monitoring the rail position with lasers and come back down and carry on milling without waiting for the copy fingers to come back in.
Another question.
Is that because you can't get S&T support to remove the treadle for the milling?
9 times out of 10, I think that's what the roots find.
Unusual.
Right, okay.
That some people zip tie them down
Yes,
and
well,
just mill through them and then cut the zip ties once they've gone through.
that would work, yeah.
Another question online from Tom. I think this is specifically about the wider head that you showed.
Right.
Is it, does using the wider heads not risk leaving a razor sharp edge at the lower edge of the lip?
That could lead that could, yes.
Okay.
There is a risk. If we would hope they would allow us to bring it down far enough that it would remove the lip completely. But if it's that thick, yes, there is a risk.
Right, okay. One last question from online from Tom again, maybe slightly controversial one. He's asking, in your opinion, is it easier to obtain product or process approval in Ireland, for example, than it would be in the UK?
I think my response is we do all our R&D in Ireland. It is less complicated.
Excellent. Any other questions in the room?
So is there no future in rail grinding then?
No, I think, don't know. Hopefully we do these tests and we'll find out one way or another. So there's feet in both camps. Yeah, people say that if you do rail grinding properly, there's no effect to the rail, so it's negative. But then how do you ensure that people are grinding correctly at all times?
When the rail grinder grinds through a unit of S&C on the stop rail and reprofiles that, does that trigger the requirement for facing point lock testing?
Only if we go down in the area where I suggest that we don't go. Yeah. Yeah, you only need it if you're going into the like.
Because I mean, obviously, stop rails often end up with a bit of a lip.
Yeah.
In towards the switch, and then the switch tucks itself underneath that lip. And when you're gauging the points, if you remove that lip, it can affect.
Yeah, it makes it wide. Yeah.
Can affect the test results of the gauging.
Yeah.
And you end up with S&T support staff adjusting the points to make them compliant again.
It's exactly the same as now. So if in the UK you send out a Harsco machine, it can grind that stop rail through there.
Yes.
Yeah, we can mill that stop rail through there.
Yeah.
We just push the blade out of the way and we can mill through it. Both machines don't necessarily do it. They do it by hand. So they can gradually remove that bit of lipping, and then they've got the people there to do the facing
Test
Why
and
not
support
test?
staff, yes.
Yeah, so I think that's still the case, isn't it?
Oh, yes,
The-
yes.
Harsco go out with a,
With support staff from
Yeah.
NRL, yes.
so I see it being exactly the same. The only thing I think it would, I fought hard and fast to get milling to the UK, and it took 6 years. I never bothered with S&C because we had 5 S&C grinder machines.
Correct.
So why have a fight about those? But in 6 to 7 years, those machines become obsolete, and we should, as a nation, as UK Rail, look at something, because milling is one pass,
Yes.
one pass treatment.
Having stood the side of the S&C grinding machine making multiple passes, I know exactly what you're on about there.
Yeah. You got less dirt, less debris. Do you know what I mean? It's one pass.
No sparks at all with the miller.
No.
You see a little bit, but you can be like
Yeah.
half meter from the wheel, and you shouldn't, but it's safe.
Yeah.
Ireland, what is their strategy? They've got 2 machines, 250 shifts a year. What is their?
Treat the whole network. Keep going round and round. Removing the damaged materials, it doesn't turn into defects.
Even straight.
Not just thinking
They're-
that's
they're-
correct,
they're-
yeah,
they're-
they're
they're-
managing their entire rail workbank, but just RCF
Yeah.
defects. And when we say RCF defects, we're talking head checking, gauge corner cracking, we're not talking squat.
And SWATs.
Right, okay, so we are talking all RCF, not just.
So they go also straights and
Yeah.
curves.
Yeah. They do the whole network.
That once per year then, is that they tell me?
No, it doesn't work out that often. It's about, takes 5 years of what they're doing to get round.
Here, we have so many enjoyed the truck.
I think
Translink have just gone the same, so they've just let their contract the same.
I think maybe it's because we've got such a big, we get our allocation as 3 weeks a year, which probably gives us 3 Saturday nights.
30 shifts a year for Scotland.
But that would only give us 3 or 4 Saturday nights. Really, this machine wants to come to Scotland and live on the West Coast Main Line.
Yeah.
That is our huge Rail Scotland part on the West Coast Main Line. So that's one of your problems when you sort of said that we're not managing the defects, is because we don't get the allocation that align with our
So
assets.
it's need another machine.
At the behest of Network Rail, what we're offered effectively. We've got it coming back again for this year. but
Is there a business case in Scotland the same as there is for Ireland?
Even when you get here, the logistics is so huge. If you think of the size of the network, the transit ships that can be involved with shifting anything around Scotland, just.
That's why in Ireland they didn't go, they went for lorries.
You can move by road and then just you get it to the site where you want it.
I don't think you could use a lorry on the Scottish Rail network, but
You've not got access points.
no.
Not green line.
It goes on at a normal level crossing. Translink didn't have enough. They built, I think, on their only small network, only 350 miles, and they built 2 or 3 wraps to accommodate it. Plus,
Probably the issue we would have is because it's contract plan, it would be required to move so slowly within our network, it would really.
5 mile an hour,
Yes.
same as Irish.
Yeah.
Irish get it on. I think they must have a lot more access points. I know a lorry wouldn't have been any good for me in Anglia on the inner. On the outer, I had 2,000 access points.
Level crossings.
Yeah, tons of them. But if you haven't got, I'm surprised you haven't got them in Scotland for farmers to cross and doing all their sheep and.
Oh, yeah, but use the word crossings.
But the level crossings are in the area that don't need milling, so.
Yeah, I was just,
I know.
when I was coming to Scotland, I thought, how big's Scotland? And I know, how much railway have you got?
Well,
And it was 70
it's got a patch the size of Belgium.
1,700.
I like to show
Your
that.
track miles is 1,700, isn't it?
2,600.
2,600. Oh, so Ireland's.
You're talking track miles, sorry. Rail miles will about 2,600, so maybe it is about 1,500 track miles. Sorry.
Yeah. I looked it up and say Ireland is 1,700.
Is that, but is that, so that's track miles or rail
Track
miles?
miles.
Right, okay.
So it's about the same.
Yeah.
I'm amazed it's the same. I thought our network would be much larger than Rod Airline.
No.
But of course, the machine there is different because the gauge is different.
The
So you have
sheep.
to do it bespoke, right?
That's the lorries are gauge changeable.
Oh, so you could take it to Spain
So
as well and do the Iberian gauge.
We're in Portugal this year, in Finland.
They have the Russian one.
No, we're not there going to Russia anyway.
That in Finland they have the Russian gauge or something similar to that. I think.
Yeah. We've got, I don't think it is quite Russian.
But it's similar. It's wider than here, I think.
Yeah, it's wide. Yeah, I can't remember what it is in Finland. But yeah, we're down at Helsinki doing the airport loop. But yeah, that's sort of one of the flexible things that we can change by sort of sizes. Yeah. Look at what you dealt, isn't it? Look at your business cases, really. And if there's anything you need, come and talk. Why doesn't it do this? Why, can you do that? Can you help us with that? We're happy to assist. And that goes nationally for any engineers. We try to come on your meetings that you have nationally. But at the moment, we've not been accepted. Thank you very much.
Yeah, thank you very much for your presentation. It was very, very interesting. It's not a subject I knew very much about, so I feel like I've learned quite a lot tonight.
Good.
Yeah, I think my biggest takeaway was actually right at the very start when you were talking about the enormous cost savings of milling versus re-rail.
Yeah.
And not just in terms of monetary costs, but also the carbon side. So
Yeah.
I think that alone probably means that rail milling is going to be a big part of the industry going forward.
It's everywhere else. It's Growing and growing.
Sorry, one was still recording.
So if you could just join me in thanking Bob just with a wee round of applause. I'll just quickly, as we said at the start of the presentation, we'll just go through upcoming events. I'll just share my screen here. Jonathan, is there a specific slide that you want me to
Go to start and I'll just kick on from there.
could you take out the problem?
I should have done.
Can you hear me online still? Hopefully you can see the PowerPoint that we've got up.
First slide.
Okay.
Yeah, so next meeting that we've got after this is Leventi Nagoy, who's part of Network Rail's track bike design team. He's a subject matter on track bike investigations, and he's going to give us an update on track bike investigation and design. And then on the 19th of March, we've got Manning and Tizami coming in from Monorail, who are kind of at the kind of forefront of remote condition monitoring. And then controversially, I suppose, with Network Rail's pushed for composite sleepers, we've got Roderick Aiken coming in from a timber merchant, tell us about sustainable timber materials. And there's actually a chap I work with, he's big passion about sustainable timber. So yeah, and then finally finishing off the year, we've got the Babcock Rail projects team coming to tell us about the works that they did at Belfast Central Station. We've got an AGM on the 28th of May. It's online and the details are on the PWI website. It's open to everyone and encourage everyone to come along. We just look at what we're doing over the coming year, and it'd be great to get more people in the committee, etc. So as many people to come along as possible, that'd be great. This is just a note. Our colleagues in Edinburgh, I've got a meeting up in January from Story Contracting, and some future meetings later in the year. I might ask the PWI to distribute this quite handy set of slides. All our previous meetings are on the Knowledge Hub, along with everything else that the PWI does in terms of seminars and articles and journals, etc., and stuff like Bob presented. And it's really powerful because personally I'll take what Bob gave us today and I'll put that through my team meeting and get everyone to discuss it as a team. So there's lots of shared learning there across the business, and you can put in any subject to do with track or even the railway, and there'll be something for you to make reference to. Yeah, just a note that PWI membership's reasonable. And everything there we spoke about, 6 meetings, seminars, community, CPD, the journal, which is lots of good detail in it as well. Yeah, I think that's us, isn't it?
Yeah, that's us. Excellent. Thank you everybody that joined online. I'm just gonna, especially those that asked questions, so I'm just gonna end the presentation. Thank you.
Thanks, Davey.